So one, thank you very much for coming. Chris and I wholeheartedly appreciate it. My name is Matt Petridge. I work with Grant Thornton. I'm out of Chicago. I am accent neutral. That's the beautiful part of being in the middle of the country. So my background very quickly is I'm a lawyer. I'm a computer scientist. I've been doing data analytics work since, I was thinking about it last night, about 1998. Back then it wasn't called analytics, it was called reporting. And back then there was really no such thing as visualization either. We were really good at doing columnar reports on dot matrix printers. I am showing you my age right now, but that's here nor there. So that's the background. That's where we're coming from. We work with Grant Thornton. We are the 5th largest accounting firm in the world. It's kind of like saying you're the 5th largest shipper in the world. One thing about Grant Thornton is not only are we all over the world, but our size allows us to be a little more agile than maybe some of the other accounting firms and other consulting firms out in the world. And what does that mean? That allows us to maybe change the ship's direction a little bit easier. And what does that have to do with analytics and visualization? Well, it's something that Grant Thornton always took very seriously, but now it's what we call a national service line. And the beauty of it is that means we get money. That means we get to hire smart people. I was grandfathered in, so forget that part for me. But we get to hire smart people. We get to do a whole bunch of things around analytics and visualization now as a natural service line. What do? We cut across audit, tax, and advisory. So it's kind of fun even putting analytics and visualization within external audit, right? Very different. And how many tax people are in the room, and when do you do analytics with tax? Well, guess what? We're doing it now. So things are really changing. It's kind of fun. It's a neat time to be in the marketplace. One last thing I want to talk about, the visualization component. I know you guys know all this, but I want to emphasize this a lot. People have done analytics forever, right? People my age, you remember Lotus 1-2-3 and Excel, and people did KPIs and benchmarks and all that kind of stuff. But the visualization component wasn't there, right? So visualization allows you to do things like seeing patterns, trends, correlations in data that you would never see without doing some level of visualization. So I've been using Tableau for about 8 years now. And one of the things that drew me to it was not only its performance and being able to do really fun things, but really it was the visualization component. It was taking millions of rows of data and being able to distill it down into a picture and then allowing someone to look at that picture and be able to do what we like to call data-driven decision making. Make sense? Right? So versus my gut tells me to do this, or we've done it this way last year and we're going to do it again this year, what we're trying to do with visualization, and again, I'm preaching to the choir, is allowing you guys to understand a little bit, allowing the end user and the client to understand what's the data trying to tell them, and then being smarter on the decision making. Here's our agenda for today. We're going to go through this stuff pretty quickly. I think 2016 is by far the year of analytics, visualization, and enterprise risk. I know that's a weird thing, but I'm going to explain to you why I think that. We're going to talk about big data. Not really. We're going to talk more about medium data, which is kind of a hot topic right now among data scientists. The 3 enterprise risks, analytics, we're going to talk about that. We're going to talk about a book. Guess what? We wrote a book. It was kind of a saying like, hey, I want to write the book on data analytics and data visualization. I know that's a little strange, but we did. And you want to know how this year's just been crazy? It is the best-selling book for the Institute of Internal Audit. Now, again, I'm not exactly sure what the numbers are. I don't know if I sold 3 compared to everybody's 1. I don't care right now. I'm on the bestseller list, all right? That's all that really matters. So what's really interesting, though, is a book around data analytics and internal audit is outselling every other book from the Institute of Internal Audit. 2, we were in Dallas last week. Keynote, Dallas Super Conference, 100,000 people. Wow, that'd be a big room. 1,000 people to sit in for an hour, listen to me go on about analytics and visualization and internal audit. We did a webinar 2 weeks ago, 5,500 people, largest webinar Grant Thornton's ever done. It has nothing to do with me. It's all about the topic, right? The topic is really hot right now, and we're going to talk about why. We're going to go some examples. Chris is going to talk about fraud, waste, and abuse, another risk element, but within healthcare. I always look at fraud, waste, and abuse as kind of a term of art within the healthcare industry. Chris is going to go over that with some actual examples as well. Okay, what's going on? Why is data analytics and visualization so hot within internal audit groups, enterprise risk groups, compliance groups? I think this is really it. not only do we have tools like Tableau that allows us to cut data in whether it's 10 million rows or 100 million rows in just a few seconds, which we never were able to do before. What's really interesting is the board, the audit committee, the C-suite, they're pushing the risk groups within organizations to not only define what the risks are within the organization, which is what they've done traditionally, but they want to understand, one, what the prioritization of those risks are, and two, show me the data that supports your reasoning of why these are the highest risks within the organization. Completely new paradigm for internal audit. I was at a company in Boston just the other day. My dad's going to be mad at me. My dad's 87, and he's great with technology, but I had a bunch of gentlemen that were probably from 70 to 80 years old. That was their audit committee, and they are zinging the chief audit executive with questions about data. And why is that risk so high? And I don't understand. Why is this region different than this region? And the chief audit executive was sitting there like, oh my God, I have no idea how to understand any of this. The reason why I was there is we're going to actually kick off an analytics initiative for them to start being able to answer those questions. So really, that's what's going on. And guys, let me tell you something. A lot of stuff you see out in the marketplace, we can identify fraud within a data set. I think that's the biggest bunch of baloney in the world. That's just my opinion. We're really good at finding high-risk transactions, high-risk vendors, high-risk employees. That doesn't necessarily mean they're fraudulent. Quick example. Anybody know what degree of roundness is? A test for internal auditors, right? How many zeros to the right of a credit card transaction? I love my American Express card, guys, and I gotta be honest with you, I rarely slide my American Express where the transaction ends in like 0000. It just doesn't happen, right? Okay. We find hundreds of thousands of transactions at 150 bucks. Is that fraudulent? A client example, we didn't know. We did a little digging. You know what happened? Remember when gas was $4 a gallon? Says this company has a huge logistics operation. Guys would go fill up the trucks. The pumps would tap out at 150 bucks, right? And they were only about 3/4 full. And then they would literally have to drive maybe 3-4 days and then fill up again. So the bottom line is $150 transactions on a corporate credit card sure looked potentially fraudulent, like something a little weird's going on, but with a little manual review, we ended up finding it was high risk, but at least we were able to identify the issue. Understand the difference? So don't let people tell you can find risk within an algorithm or within Tableau. Again, focus on identification of the high-risk elements, whatever they may be, and then there's going to have to be some manual review behind it. Hey, okay, I kind of killed my own slide here a little bit. But again, the board, the audit committee, the C-suite, expectations have changed. Guys, the other thing, board members a lot of times work on other boards, okay? So it's kind of funny when you go into these meetings and they're like, hey, the company A that I'm working with, they're doing all this data analytics stuff and they're talking about, how come these guys aren't? All right, so again, another reason why risk groups within organizations are getting pressure to do more around analytics and visualization. Let's talk about the last piece. We'll talk about the book in a second, but we interviewed 360 chief audit executives, directors of internal audit, directors of enterprise risk functions. You know what the number one request was? By far, about 80% says, I want to be able to do predictive. Predictive what? Predictive analytics. What do you want to predict? I'm not sure, but everybody's talking about it, and I want to do something with predictive. Okay, fair enough. Let's talk about that, though. Predictive, right, the one job where you can be right 5% of the time and still have a job, well, that and the weather person, right? We can do pretty slick predictive stuff right now. So what are we good at? We're pretty good, remember, keep pretty good relative. We're pretty good at identifying a third-party vendor that may commit an FCPA violation in the future. Foreign Corrupt Practices Act, facilitation payments. Everybody know what that is? Right? There's some countries around the world where a vendor that's working for me can go, they call it a facilitation payment. Basically, it's a bribe. And they can bribe a government official in order to get a permit, to maybe be able to work within a particular country, to get a warehouse built, whatever it may be. If you are a US-based company, I know somebody who knows FCPA better than I do is going to say, Matt, you can actually do a facilitation payment. It's the way you track it. You really can't, but that's just, again, how I look at it. So what else can we do? We can predict which employees within a company may commit time and expense fraud. Is it for sure? Nope. But if I'm a company that has 100,000 employees, we can identify a watch group of maybe 50, right? And what are we trying to do? We're trying to make the internal audit groups, the risk groups, the control groups more effective. And how are we doing that? We're eliminating things like random sampling. Any statisticians in the room, I'm sorry, get rid of sampling. That stuff's got to go. Forget it. We're done with that. I'm really struggling with someone who says, oh, we have a set of 100,000 records and we're going to sample. Why? Run the test through the whole 100,000. Hell, we're doing it with 500 million. It doesn't matter. The technology there, the speed is there to be able to look at every transaction within a set. Right? We'll talk about big data in a second. But again, sampling, get rid of. Predictive, we can do it. Again, it's not perfect, but what we're trying to do is allow risk organizations to do more. In the past, when people were being laid off, they'd say do more with less. But now we're doing more with the same. That's really our goal. The goal is to make auditing, control checking, any of our regulatory components that we have to do within an organization more effective. And how do we do that? We focus on the high-risk transactions. And how do we do that? We use analytics and visualization to be able to identify those transactions, and we're going to show you exactly how we do that. All right, let's talk very quickly. I know I jumped right to prescriptive or predictive. Here's kind of the, oh, can you believe that? You're going to go back the old-fashioned way. Here, Chris, you can build this. Thank you. Thanks. If you, or forget it, we'll do it there. Yeah, whatever, that's fine. It's unbelievable. See what happens when you have like 8 cups of coffee before you get here in the morning? Okay, descriptive analytics, what are they? Kind of tells me what happened, what's going on. Next piece, diagnostic. All right, that happened, but why did it happen? Predictive, well, that's going to tell me what's going to happen based on what happened in the past. All right, now prescriptive. That's kind of the one that's pretty far out there. There are some companies that are doing it. Example, descriptive analytics tells me that I did 100,000 widgets this year in the sales. Okay? Diagnostic will tell me, you know what, the reason why we did 100,000 this year is my southern region was up 40% in terms of sales. Okay, fair enough. Predictive will tell me, based on the fact that you did 100,000 in 2016, and based the breakout of the regions and how that all was kind of came together for 2016, predictive tells me I'm going to do 200,000 widgets in 2017. And again, that's just based on the historical analysis of the past. Prescriptive tells me if you're going to do 200,000 widget sales, prescriptive tells me exactly what I have to do from a resourcing, CNC machines, resources, staffing, whatever I need to be able to do to produce 200,000 widgets in the upcoming year. Make sense? Did you fix it?
It works.
Thanks, Chris. Hey, look at that, beautiful. So does that make sense, kind of the 4 levels, right? And it's funny, you're doing all these interviews with people, and everyone's like, I want predictive. Okay, we'll get there. That's fine. It's real, and but you know, sometimes we have to start kind of at the beginning to work our way up. Gary King, really smart guy. He's from Harvard. I love the comment that Gary made, and I couldn't agree with it more. Really, the big data revolution isn't necessarily about data. It's the fact that we have technologies like Tableau that can cut that information in seconds now. Where, don't you remember everybody used to do models in Excel? At least I remember this. And people would say, oh my God, it takes all night to run the model, right? And then all of a sudden they figured out that they did one thing wrong and they have to fix it, and then it has to run a whole nother night because they had to change one variable. Oh my God, it would drive me bananas. But that's the level of technology that was around. You know, this was just 5 years ago, all right? A 900 million row data set of static data. You guys, there's no doubt about it. 3-4 years ago, I would ask everybody in this room if that's big data, and everybody would raise their hand. It's not. Okay, static data, 900 million rows, Tableau, and a decent box can cut that in about 45 seconds. All right? If you have 500,000 rows and it's changing every 15 seconds, okay, that's a big data issue. We'll talk about that some other presentation. But static data, billion rows, that's not big data anymore. So, why is that important? The hot topic of the day, someone says to you, hey, let's talk about big data. You tell them, no, I want to talk about medium data. all right? That's kind of the hot topic right now. Medium data is the idea that it'll give you all the insight, all the data-driven decision-making that big data will, but at a reduced data set. And how do we do that? We eliminate the tails, okay? Histogram, bell curve, pretty simple. Long tail right, long tail left. And what do? This is where all the information lies. Eliminate the tails and focus on the analysis in the middle. Make sense? Right? That's medium data. Shortens up your processing times a little bit. If you have a massive data set, obviously it'll increase performance. And the beauty of it is you get all the insight and information that you would get out of a big data set and just eliminating the outliers. Okay. Again, can be structured, unstructured, not that really important. The bottom line is it's just a data set. It's roughly, if you eliminate the outliers, in most of the cases, you reduce the total data set size by about 35%, okay? And again, I stole my example. You know, a billion rows of static financial data, yeah, it's big, but that's a medium data set right now. That's not big data anymore. So Chris will talk a little bit about the 4 V's of big data. I'm a big velocity guy. If data's changing every 15, 30 seconds, and you have 500 million rows, you've got a massive velocity issue, you've got a big data issue. But if it's static data, nah, not really. All right, let's talk about a few things here in terms of historical, continuous, and the future perspective. How do risk groups look at information? These are really kind of the 3 ways that I thought of in terms of doing client work and talking to all these people about what they're trying to analyze and see. This is a historical perspective. You can't call it a look back. If there's any auditors in the room, everyone said that's a term of art for external auditing, so you can't call it a look back. But what we're trying to do here with historical data, I love this type of analysis. So this is T&E data. Pretty simple. We take an individual and we look at his or her amount of transactions or the amount. So it's the number of transactions and the amount, let's say by quarter, by year. Okay, that's what we're looking at on top. Then what we do is we compare this to the averages for maybe that individual's department, maybe the same level. So you're a manager in purchasing. I can compare you to other managers within purchasing. And then I can look at the number of transactions you're doing as compared to other people that are situated similarly to you. Make sense? Both from a number and from an amount perspective. What are we trying to do here? Identify anomalies and outliers. That's really it. Right? That's from a historical perspective. It works really, really well. You know what else works really well? Is when you see a spike like there. So you've got a fairly flat trend from the number of transactions, and all of a sudden you see you're at 300% with the 2,396. Why? Again, is it fraudulent like we went back? I don't know. But it's probably a high-risk anomaly or a high-risk outlier that needs to be looked at. All right? Another example, client example using this kind of analysis. We're going through and we see a massive spike, not in the number of transactions, but in the amount. So for a particular month, for a particular quarter year, this individual was up over 400%. We dig down a little bit. So, you know, everybody knows in Tableau you can click on a visual and then do the drill down and see the granular data, the kind of the most detailed level of information that makes up the graphic. And what do we see? We see a corporate credit card transaction. I'd like this person's credit card limit for $150,000, okay? So I'm like, wow, that's pretty interesting. What happened? Their business unit had a conference at a hotel, and this individual slid his card for the entire conference, all the rooms, all the food, pretty much everything at $150,000. You know what he wanted? Points, 4 free flights. Okay, so what do we find? Again, was it fraudulent? Yeah, well, I don't know if it was fraudulent. Was it against the T&E policy? Absolutely. All right? So something else that's interesting about that example, think about what's going on here with groups, risk groups, internal audit groups, controlling groups, regulatory groups within the organization. As they find things like that, they're able to drive process change back into the business. And that's something that internal audit, I know I'm focusing on a little bit on internal audit right now, but internal audit hasn't done much of that. All right? The beauty of it is now they are. It's really raising the value of internal audit within the organization. So not only do they have to identify the risks, not only do they have to show the data that supports that, not only do they have to show why the prioritization of the risks is what it is, but now they're able to say, hey, you know what, maybe we make a change to the T&E policy. Or another example, fuel cards for trucks. We found a guy who put 22 GPS units on his fuel card. It's a fuel card, right? What did we find out? That some technology at the point of sale doesn't know that it's only supposed to be a fuel card just for fuel, right? So again, things had changed, and a really neat process change that internal audit's able to drive back into the business. Make sense? Continuous auditing, continuous monitoring. This is really interesting. Okay, everybody's talked about it. We had those interviews I talked about from the book, 360. We had everyone who participated in the book, we wanted them to blue sky what would be the ultimate solution, all right? And I took all that information and I kind of sat on it a little bit and tried to not get much sleep and came up with something, and we're going to actually show you how this works. It's also in the book. But what people want to do is real time. What does that mean, real time? I don't really think it means like every minute. Okay, real-time data within risk groups can be daily, they can be weekly, doesn't have to be every hour. It really depends on what you need. But fundamentally, what's happening here, this is risk ranking all the employees within the organization every time a new data set gets flushed in. So think of a Tableau extract, right? And the extract goes out to SQL Server or Oracle and pulls in the new data. We typically do that 1 in the morning, 2 in the morning when there aren't a lot of people using the system. Once that new flush of data comes into the extract, those risk rankings get redone, and I have a new group of employees who may commit a T&E fraudulent violation, and we can recalculate every time the data comes in the door, all right? Then again, I'm going to show you this live, so I'm not going to go over too much of it. This is an overall risk profile of all my employees. It basically tells me how effective my T&E policy is. Think about if we're doing this for vendors, and I'll show you the vendor example because I think that's a little more powerful. We risk rank all the vendors for potentially committing an FCPA violation. Then the histogram below shows how effective our third-party vendor management program is. So if we make a change to that program, fundamentally what should happen? If we make a change, what are we trying to do? We're trying to reduce the risk, the overall risk of all my third parties, correct? Right? I mean, that's why you would probably make a change to your vendor management program, fundamentally. If it worked, what happens to the histogram? Which way does it go? Lower, right? If 0 is my least risky vendor, so we're sitting in an entertainment company, they make a change to their vendor management program. This pops so hard, basically this graph went over here. What's interesting though, okay, so the change didn't do what they expected it to do. The beautiful part about it though, is I could very easily tell the day that it popped, right? Just by using the date function within Tableau saying, October 1st, when you did this process change within SAP, this was all about reconciliation of general ledger entries. Sarbanes rule, every GL entry within this organization had to be cleared within, or reconciled, not cleared, reconciled within 90 days. So they made a change to the way SAP does auto reconciliation, and it went from basically on average maybe a 3-day delay in the reconciliation to about 127 days, blowing their Sarbanes controls, all right? And also going back to the company, I swear it wasn't Grant Thornton, that made the change to the rules, and what the heck happened? And if we had more time, we can go in more detail, but it was really amazing to be able to see kind of how the change, I don't know a better way to say it, screwed everything up. At least ultimately, we were able to identify the data that occurred, backtracked into what exactly changed. We figured that out and then backed that out as well. So that's the kind of stuff that continuous auditing, continuous monitoring allows you to do. But again, I'll show you that live, which is more interesting than looking at a static picture. I love this. I wish we had an hour to talk about stats, future predictive analytics. This is just simple correlation coefficient. Everybody know what correlation coefficient is, right? 2 variables, how one variable can affect another variable. This is a single linear regression. So 1-to-1 variable. So how does that mean? If I'm hungry, I tend to eat. Okay, that's literally the correlation. Correlation goes from 1 to -1. All right, highly correlated, we can argue, but maybe it's 0.75 to 1, either again negative or positive. If it's positive, as one variable goes up, the other goes up. If it's negative, as one variable goes up, the other variable goes down. The kicker, though, around a correlation coefficient, which you can do really nicely within Tableau, there's a window calc function for correlation coefficients. Remember, the two variables have to be linearly, if that's the right word, has a linear relationship. This is a scatter plot, and all we're trying to do is a linear relationship to check out if those two variables, if the correlation coefficient is workable, for lack of a better word. That's a pretty decent linear relationship between two variables. You know what this is? I did a great project. Well, the project was great. I'm not saying the work was. On Hurricane Ike for TWIA, the Texas Windstorm Insurance Association. So TWIA gives insurance to homeowners on the coast because the privates won't give you house insurance if you live on the coast and the Gulf. Where all the hurt, especially obviously during hurricane season. This is actually an analysis of the amount of time it took to pay a claim and whether or not you would litigate that claim if you didn't get paid in a timely manner. So what was happening here? We had a whole bunch of claims that weren't resolved. Now, Ike happened in 2008, so this wasn't that long ago. So the claims are out there 6, 7 years. So what would you think? If you had a leaky roof and you got paid in 30 days, would you be happy? Yeah, right. What if you were paid in 180 days? Right, because you probably have some plastic tarp on your roof, you probably still have water leaking in, you might have more damage. So what we were trying to figure out, we tried to come up with a litigation model of which claims would ultimately become litigated, and I kind of thought, just like you, if someone didn't get paid within 30 days or 45 days, it's going to kind of tick them off, right? And ultimately have maybe them litigate that particular claim for more money. Now, there's a whole host of variables around Ike and everything else, and to be honest with you, my model kind of collapsed, for lack of a better word, for a whole host of external reasons. But when you take a whole host of variables, so maybe how fast you got paid, maybe how fast, think about this, how fast your neighbor got paid. So your neighbor had roof damage as well, but they got paid in 30 days. You got paid in 180 days, that's going to tick you off even more, right? Now we're getting closer to the way State Farm, Allstate, they do their predictive models as well. So they do use a lot of socio-demographic data. How about this? One of the other variables, educational level between you and your neighbor. How much money your neighbor makes is compared to you. If you make more, you're less to litigate. If you make less, you're more likely to litigate. Really some interesting stuff. When you take all those variables together, you do a linear multiple regression model. This isn't about stats, I'm just throwing the term out there, so it takes a whole bunch of variables to predict one variable. So those are all the variables that we looked at to predict whether or not a claim would become litigated, and this was the basis of that. For you big data people, I want to talk about smooth scatter plotting for 1 second. If you had 100 million observations, and you tried to scatter plot 100 million observations, what would my scatter plot look like? Well, it would be just a bunch of marks, right? So, smooth scatter plotting, a big data technique for doing scatter plots. Break up your data into 10 equal buckets, or maybe 15 buckets, whatever you want to be. I typically try to keep it between 10 and 15 at the most. So if I have 100 million rows, I do 10 buckets. Each bucket has 10 million rows of data, right? Calculate the mean for each bucket, and all you do is calculate the mean from bucket 1 against y against the mean to bucket 2. Ultimately, then I only have 10 points to plot on my scatter plot. That is called smooth scatter plotting. Make sense? Kind of an easy way to get through big data and if you want to actually do a scatter plot. Okay, the book's fun. We already kind of talked about it a little bit. What were we trying to do? Why did we write the book? Why was it even important? Well, it was important to us. We wanted to understand what was happening within risk groups, within internal audit, what they were trying to do with data analytics. 2, what they were doing now, what they wanted to do in the future, what worked and what didn't work, okay? 3, the gaps. We wanted to look at software. What's the number one tool that internal audit groups, control groups are using for analytics right now? Thank you. God forbid, it's still Excel. Nothing against my Microsoft guys that are here in the room, but there's other things that people can do, okay? What's the, and we talk about the future, give me the number one problem that risk groups within organizations are running into to try to start an analytics program, by far. Who said that? Access to data. And not only that, it's access to good data too, but you nailed it on the head. What's changing? internal audit groups, risk groups, control groups are actually putting data people within their organizations. And, hey, I'm an ex-IT guy. I love IT, but fundamentally, sometimes they don't get the support that they need. So getting someone that kind of understands the technology a little bit to pull data, it's really kind of changing the way internal audit, other enterprise risk groups are actually being staffed. Those are the chapters. We make, how's this? We make no money on the book. If you do ever buy a copy of the book, it all goes back to the Institute of Internal Audit Research Foundation to do more research around analytics and internal audit. So kind of a kicker, you got a best-selling book. Again, maybe I only sold 3, and we don't make any money off of it anyways, okay? So key takeaways, absolutely the truth. Most internal audit groups, most risk groups are in the infancy of doing internal audit, infancy of doing data analytics, right? Everyone's saying, but that's okay though, because you could do some really cool stuff, even if you start small and just do a few basic things, okay? Really, you can do some very powerful stuff that has great ROI without spending a lot of time and a lot of money. All right, we talked about the data, huge issue. We talked about chief audit executives. Everybody wants predictive, there's no doubt about it. In-house staff, we're even staffing our external audit teams differently. We're putting more, if you're an external auditor, what do you typically? Finance, accounting, great degrees, but we're kind of saying, okay, we can teach people how to do audit. We really can't teach people logic, and we want people to understand logic as we include more analytics type work within both our internal and external audit processes. Okay, and then financial results. Easy to get a high ROI on a project that only costs 50 grand, okay? It is. If you spend 5 million, it's a little bit different. Tableau is something, the CIO of a bank told me, he says, Matt, Tableau is a great micro solution. Like, I didn't even know what the heck that was. What is he talking about? It's not the implementation of an ERP or CRM. It's a point solution that can go into a particular department within a particular business unit. You can maybe spend X amount of dollars, we're not talking a lot, and get a huge return. And people love the output, right? And then once they see that there's a success, then you can build from that. So something to think about. Okay, let's go through a couple examples. Whew. I'm doing good. We're on time. It's a miracle. All right, so let's do, that's all right, let's start here. And let's do, okay, we talked about this. This is forget time and expense. Let's do vendors. Okay, so what did I just do? Now, talking about performance of Tableau extracts, not that Tableau needs any more promotion at their own user conference, but there's maybe about 1 million rows of data sitting behind this. So I love the performance, and I'm sitting on Chris's laptop right now with like 5 other things open. So what are we doing here? We risk rank every vendor for the potential to commit an FCPA violation, right? We talked about this, right? This kind of is giving us an idea of how our vendor management, our third-party vendor management program is working. My first question, if I look at the risk ranking, which is 69 here, that's on a high, 0's a low. What is your first question? If you look at that vendor and it's ranked 70 or has a risk ranking of 70, what would your first question be? Oh, you're perfect. Why? I'd have the same question as well. I click on that. I didn't mean to do that. Chris, I don't like your mouse. And we go to all test detail. So what is this showing me? I am a box and whisker plot fan. Everybody kind of gets screwed up. Sometimes I do too in terms of how to read these things. So what are we looking at here? Take a look at the top. For an FCPA, we're running those 8 tests. Things like payment to high-risk vendors, where the payment description equals facilitation. Remember I told you there's some countries that allow facilitation payments? No kidding, your third-party vendor will actually write on the invoice that they submit to you for facilitation payment. Okay, they don't put bribe typically, but they will put for facilitation payment, or they leave it blank. Payment to a high-risk vendor, a payment in a high-risk country. Data analytics, you guys, don't just think, and again, I'm probably preaching to the choir, don't just think your own internal data. This uses something called CPI, the Corruption Perception Index. Anybody hear of that? CPI is available on the web. I think it's updated every 30 days. It gives you a country-by-country risk ranking of working within that particular country. All right? My favorite country in the world, Somalia, in North Korea. They're always pretty much ranked the most risky to work with. So what do? You mash up that CPI list with where your vendors are working, and then that becomes that test result. World Bank, anybody ever look at the World Bank blacklist? Every month, World Bank comes out with a list of fraudulent companies and fraudulent individuals that they will not do business with. They will give you the reason that they are on the blacklist. They will also give you the number of days that they're going to be on the blacklist. Take that list, mash that up with who your vendors are actually doing business with. Again, it gets a little tricky, you guys, in terms of matching names, right? Everybody knows one space. So use things, there's SoundX technology, there's phonics technology, there's other programs that we use that say, hey, this name sounds just like this name. So it kind of tries to read it and figure out if the names match. Okay, so there's a whole host of ways that you can do that. I'm going to show you that stuff in a second. But here are the test results. These 8 tests. Here are the results. Add them up by 8, divide by 8, and there's your risk ranking. And what I like doing here is you can see the test score for number 1, payment to a high-risk vendor. For this particular vendor, the score was 125. The average score for that test across my entire vendor population was 59.6. So I can start seeing why this vendor is ranked so high in terms of riskiness. And we can do other tests as well. So this guy scored, let's go to 3, 125 on 3. You can see, again, the average across my vendor population, 21.4. Right, so something's really wrong here. But this is the beauty of it. Very easily now I can kind of understand what's going on from this vendor perspective and why their risk ranks so high. I really liked the highlighter function in 10. I don't really think it fits here, but I wanted to throw it in anyways just because I thought it was cool. So anyways, you can pick any of the different vendor types and it highlight. I just think it's a really great feature. I was messing around with it last night. I'm like, I got to work it in somehow. Okay, weightings and scorings. Let's talk about this very quickly. What's kind of fun about this is the weighting and scoring for each test, we allow you to adjust on the fly, right? Because whether it's your external environment, your internal environment, the type of test, what you're trying to do with an organization, the weighting and the scoring is going to change. Everybody understand that? So if at some point I think payment to high risk, let's go do something better. The World Bank risk ranking. If I work with a particular vendor on the World Bank risk ranking, I think that is absolutely terrible. All right, so that's test 7. So I'm going to up from only 25%. I'm going to go to a weighting of 200%. When I go back to my riskiest elements, did you see everything just get recalculated and flip? So now I'm going to have a different vendor that's risk ranked the highest because they are working with a high risk vendor. I've got my weighting and scoring. I'm able to adjust on the fly. If you use Tableau Server, you can save each of your weightings and scorings on different sheets on the fly. So you're kind of like, hey, here's one where I'm focused on high-risk vendors. Here's where I'm focused on particular countries. Okay, a couple of things. Chris is giving me that funny watch look, saying I know I'm getting to the end. Real fast, I'll skip Benford's. As much as I like Benford's Law, we'll skip it. This is the mashup of CPI and where this vendor is particular working. Yellow, big, is good. Dark red, bad. Okay, pretty simple. Okay, we'll go through it fast. So what I can do here very quickly is I am doing a quick analysis on show me the riskiest countries where this individual is working. If we were connected to the net, you'd see the rest. And there I always pick on Somalia. Hover over. I got 599 transactions. I'm at $250,000 per transaction within the country. Again, the beauty of it, you guys, this is 1 million transactions sitting behind this. Right? Very quickly, I can go to a particular country. I can see the risk ranking. I can see what I'm doing in that country. I can drill down into the data. More analysis than you could ever do with a spreadsheet. All right? Literally, this can happen in seconds versus hours or days. Okay? Let's show you. Let's do this. So I'm going to time and expense. Let's do Benford's. Anybody, you know what Benford's Law is? Benford, a statistician in no, he was not. I'm sorry, he was a physicist. Everyone says it's kind of weird that a statistician came up with this. In a natural occurring data set, Benford predicted how many numbers would begin with the number 1, the number 2, the number 3, and so on and so forth, okay? So Benford says that the number 1 in a natural occurring data set should occur 30.10% of the time. In this data set here, it's occurring 23.4%. We're almost 7% low. In a Benford's investigation, that's something you want to look at, right? You shouldn't be 7% low. Magic number, everybody says, Matt, what's the magic number for what certain percentage would you say, oh, there's something going on? I don't know. Honestly, it literally, you could have a 0.5% gap, and it could mean something to an organization, or we can have a 7% gap here, and it maybe doesn't mean anything, but it's a great way to just cut 1 million transactions to figure out potentially 2% gap, 3% gap, 2% gap. Here we have almost a 6% gap in all the numbers that occur to 6. Remember, it's got to be a naturally occurring data set, though. And people kind of argue about that definition a little bit. But if there's anything that's kind of forcing numbers to be set to a specific amount, Benford's won't work, all right, because it's not naturally occurring anymore. No, all I'm going to do now, last thing, and then I will get out of Chris's way. So you've got, we'll skip that. I just love this. I want to just show you this. You are a life sciences company. You have 100,000 vendors around the world. Your internal audit group cannot get around that population to begin to figure out who to audit. And there are so many invoices per third-party distributor, you can't even figure out which invoices to audit within each third-party distributor. This went live at the client about a month ago. I love this. Okay, this is all of their vendors around the world. 100,000, there's probably about 20 million transactions total baked into this. What are we trying to do here? This is just our variables that we thought were important. Discount percentage, quantity, profit margin, and then the correlation between maybe a drug expiring and how the price of the drug, if it's getting closer to expiration, what do you think the price would be from a distributor standpoint? Can't hear you. What would the price do of a drug? If I'm getting close, I got to sell it. And if the drug is getting close to expiration, I'm dropping the price. Absolutely. And across the board, you could see, good point. Not that this is generics. You could see the correlation is negative 0.5 across all the vendor population. So that's pretty much what's happening. But take a look at my max, 0.26. We've got a group of vendors that as the drug is getting closer to expiration, price is going up. Doesn't make sense. Okay, so now you're starting to understand how we're doing the risk. So we calculate the average discount percentage, the quantity, the profit margin. We put a little window around it. That's where it says discount plus or minus from the average. If you fall between 9.32% and 6.21% from a discount percentage, we say you're pretty not risky. You're kind of within the norm. But if you go high or go low, we've got algorithms running behind this that's increasing the risk value. We do that for discount percentage, quantity, profit, and then at that point, you can see the red vendors are high risk, blue are in the middle, my few green are low risk. Bottom line, what does this allow the internal audit group to do? Identify the top 20 high-risk vendors around the world. Then, Chris, go to invoice analysis, and then I'll be quiet. Just, I promise. Okay, last piece, and then I'll shut up. Remember the Atlanta student-teacher issue we had on standardized test? Remember that? One of the reasons that Atlanta was found was most statisticians will tell you if a number is 3 standard deviations away from the mean, there is probably some physical manipulation going on within that particular number, all right? So what was happening? I would take my standardized test, the teacher would look at all my wrong answers, he or she would erase my wrong answers and fill in the right answer. That is called a wrong to right erasure. Right? And then we looked at 3 standard deviations away from the mean, and it started guiding us towards Atlanta. Same thing here. So for this particular invoice, the amount order is 4 standard deviations away from the mean. There's something wrong with that invoice. So not only did we just risk rank all the vendors, now by using the 3 standard deviations away from the mean test, we are risk ranking all of the invoices, and bingo, now we're focusing our audit on the highest risk vendors within the highest risk invoices. Chris, it's all yours.
Thank you. I was joking with Matt. He probably never heard this before. Maybe you did. I said, you were like the, first of all, he does an excellent job in his presentation, so always happy to present with him. But I said, because he's known to be a talker. I said, so on the phone earlier today, I said, I got to make sure I signal you because, you're like the Joe Biden of data analytics. You can go on and on and on. But like Joe Biden, people like you. So I'm going to close your vises. So, just in my role, I am Well, Matt is, a specialist who goes really deep in the areas of, risk analytics, audit. I view myself as more of an architect who just happened to stumble upon Tableau several years ago while I worked at Deloitte, and then I brought that to Blue Cross Blue Shield, North Carolina. My friend Beth is sitting back here, so she's going to recognize some of my examples. But these are typical types of solutions and technologies that we use when we're doing any type of outlier detection. Descriptive analytics, unsupervised learning, that's Tableau. That's using data visualization to do descriptive intelligence or analytics. And as Matt mentioned, predictive analytics gets a lot of hype when we're doing outlier detection. This is when we have a known set of rules or outcomes, such as a scoring model for fraud, for fraudulent transactions, right? Where we know certain characteristics of these transactions will lead to higher risk. And so Matt showed some examples of that. A newer technology that we're getting into, graph analytics. Anyone using graph databases? Okay. And then big data. So I have, I agree with everything Matt says about medium data. I think it's a great point. There are instances where you want to use big data for outlier detection. And so in terms of descriptive analytics, where we see this is very used widely and very helpful is when we're trying to uncover new types of sketchy or even fraudulent activities. And Matt said we don't know for sure that they're fraudulent, but because the bad guys are always looking for new ways to innovate, and if we're too reliant on things like predictive modeling, we're not always going to be, they're going to be a step ahead of us in most cases, right? Graph and social network. I have a couple examples at the end of what that is. But this is using a different storage mechanism for your data. This is considered a NoSQL database. But here we're actually storing data, entities such as the patient and the prescribing provider that I'll talk about are nodes in the data. And their relationships are called vertexes or vertices. And it's just for large volumes of data sets, it's just a more efficient way to actually store and query data compared to relational databases. If you took a query that you'd run against a graph database compared to something you would run against a graph database, it'd be A, much faster in the graph format, and B, just a much more simpler query. I have a reference to Mr. Mark Jackson, who did some examples of this at his healthcare organization that I'll share that link at the end. In terms of big data analytics, you hear a lot about, a lot of hype around it. It's definitely something that's overused, but in this case, when you think of the 4 V's, volume, velocity, variety, veracity, typically if you have only one of those, let's say if I have a lot of data, I usually have a traditional type of solution that can handle that. It could be the Tableau data extracts, could be a high-performing columnar database. If I have such a need to capture streaming data, a lot of our tools now have mechanisms to work with what's called complex event processing. So whether that's a technology like an Oracle Golden Gate or some of the Microsoft technologies that can handle streaming data. Now, if you have multiple combinations of these, if you have a lot of unstructured data, free-form text that you're capturing out of notes, audio, video, if you have all these non-traditional, non-structured data sources, that's where you're starting to look at NoSQL or even big data types of solutions. I'm going to talk now about this data discovery. What is data discovery dashboards? For me, it's opening up Tableau, loading lots of data in Tableau, organizing it and structuring it in a way that somebody can come in, say in this case, in the case I'm going to show a little bit later on, it would be an investigator for fraud, waste, and abuse. But they do not have to get into the data. Someone's already prepped the data, in this case in Tableau, data extracts. They've organized it in a way that I can go into a dashboard self-service and I can start exploring different trends, different patterns, and I can start looking for some of those outliers. This is my first data discovery dashboard. This was when I was with Blue Cross Blue Shield, North Carolina. Beth, how good was our Teradata data warehouse in terms of performance when you come in the morning? Would you say it was good, bad, awful? Okay, well, when this data says otherwise, and this data was actually, the problem was I was getting reports from our DBA saying, hey, here's the longest running queries. When I was asking what's going on in the data warehouse, they'd send me a snapshot, here's what's happening now, or they'd send me a report written in business objects, here's the longest running queries. And I said, this is the wrong way to tackle this problem. I think there's something else going on there. I think there's rogue programs running on it. I think there's scheduled reports from a business object server running on it. And since I was part of the Tableau Center of Excellence, I knew that Tableau was not the culprit because I made sure my extracts were refreshed late at night when no one was on it. But what I started doing is I started collecting data from our Teradata data warehouse. The challenge was that query log got purged after every day. So I set my Tableau server up to collect every single query run in Teradata. I then I made sure I was capturing the IDs of the actual application. So it's a SaaS product. It is business objects, Cross Report Server or Web Intelligence. It's Tableau Server or Tableau Desktop. So I was able to get enough metadata to determine what was running on that. And then as I was collecting this every night in incremental load, because the warehouse was getting purged, I eventually ended up with 6 months of data, over 1 billion rows in my extract. I was able to then talk to the DBAs about, this is not a one-time thing. You have ETL jobs running. You have individuals who are just running reports in production at 8 o'clock in the morning when I come in to try to do some work. Teradata is not responding. What's going on there? We don't know. Well, in this case, the red on the top right was showing that it was one individual running hundreds of reports at 8 o'clock in the morning when everybody first is coming in to get to work. So we worked with the DBAs, we worked with the individuals, because we were able to get user IDs, who's running these applications, to shift some of this work to earlier in the day. Since I've left Blue Cross Blue Shield, which was last year, now I have people in IT using Tableau to do this type of analysis on their ETL server, because there's challenges with ETL performance and also just in general IT business and other business processes. So it was just a quick win, but it was my first attempt at loading massive data in Tableau, in this case, 1 billion rows. Now, in my demo I'm going to show you is on fraud, waste, and abuse for pharmacy claims. My wife is a PharmD. She happens to work at Blue Cross Blue Shield. So she's just someone I talk to a lot about this problem of rising healthcare costs, rising costs with prescription drugs. It's been a huge issue especially with the Affordable Care Act population. But when I started diving into the data at a number of websites that I listened down here, I was looking at total dollars. How much of our almost $3 trillion in healthcare spending is actually pegged at fraud, waste, and abuse? And that's almost 10%. And this 270 is actually a year behind the actual number of that 3 trillion, which I believe we hit last year. So almost 10% of our entire healthcare spending is fraud, waste, and abuse, and it could be possibly even more of that. In terms of Medicare, you have between 60 and 70 billion, so about 10% of that program is fraud, waste, and abuse. And that all affects us, right, as taxpayers, as people who get health insurance. Those are things that affect our dollars, our income, and also our premiums for health insurance. So to me, that's a big deal. At a more personal level, and I'll share a map with you on the other screen, but prescription drug abuse is, especially with opioids, is becoming just a massive problem in the US. And so just in terms of the spending, we're looking at just in opioids, primarily opioids, $25 billion in annual spending on abuse. And then if you start adding in societal costs, productivity, law enforcement, things of that nature, they're talking 70 billion in some of the studies I've been reading. So, and then the number of people dying every day from opioid abuse is increasing. So to me, this is a prototype I did with some claims data, just a little bit more data points on that. And so you see the dark purple. I didn't do that on purpose to match the GT colors, but it was just like that. But just certain states, you look at some economically depressed areas, and they have much higher, and sometimes 3 times the rate of opioid painkiller prescriptions than the states with the lowest rates. Providers across these different regions don't necessarily have the same agreement on when they should prescribe these opioids and how much they should prescribe. So when I show you my data set, you'll see a wide range of values in terms of how many pills of OxyContin, for example, are being prescribed. And a lot of these increases is due to people using them non-medically. So people, and I started talking to my wife, and I was actually working on this prototype. I said, what are some of these instances that I'm finding in my data set? And she said, those are likely people in what they call pill farms, where it's actually a business of filling large prescription drugs, and then it becomes a business for people to illegally transact in drugs like opioids. So just how I got this, got started in this, I wanted to tackle a problem that I could find data on. And I had several years of anonymized pharmacy claims. I wanted to look at the most abused drugs, so I went to, I think it was either CMS or Health and Human Services website to find out what are the top 10, because I didn't want to look at all prescription drugs, because while Tableau has great performance, that I think in my data set I had in the tens of millions of records, so I wanted to cut that down. And then I started to have to understand some more around baseline behavior. For example, when I'm getting oxy for a painkiller, what's the typical amount that I get dispensed? What's the typical day supply in the pharmacy terms? And then I'm detecting anomalies. If I was doing this for my employer, if I'm working at Blue Cross Blue Shield, I would then also find these anomalies, and I would report these anomalies. I would get an investigator involved to actually go investigate if there's any opportunities for repayment or even outreach to providers who are maybe prescribing these wrong. As Matt said, you don't always want to assume fraud. There's outliers, especially in healthcare data. There could be outliers, and there could be a reason for those outliers. So you don't start off by assuming fraud. I'm going to show you an example. When I first looked at it, I said, yeah, that's fraud. But and the key for that, as I get into my dashboard, I love when PowerPoint does that to me. And so these are the top 10 list coming out of, I think it was the Health and Human Services website. And so I took those top 10 lists, I took all my pharmacy claims, I did the grouping feature in Tableau to just group by those. I looked at, then I had to understand which were the branded versus the generic. So, a lot of these had generic versions, so I had to make sure I grouped those together. Then I sorted them by total dollar amount in terms of the amount spent on these prescriptions. I looked at things like the total amount paid out by the insurer and the total number of prescriptions by the patient. I looked at the amounts that were being prescribed. I then looked at which physicians. I looked at a scatter plot on which physicians were actually prescribing these. I used things like level of detail calculations. Has anyone been using LOD? It took me about a year to figure out how do I use these things? When are these useful? And for what I've found is that when I'm looking at a large data set and I'm looking at individual data point and I want to understand for this data point, how does this show me maybe the average for all the other data points like that, and maybe not necessarily using those same dimensions in my viz on my shelf. So LODs might take a while, but I found them to be very, very useful. And then I have some other views here. So I had my highlight table. So I wanted to know what were the typical, when I get a prescription, you see in this case, 30 pills for that prescription. And then I go down and I see it's very rare when someone has higher than that, but it's not unheard of. So in this case, there were 3 prescriptions that had a dispensed quantity of over 400. I have Matt's favorite viz, the box and whisker, to start looking at just when I start looking at individual data points to see where they fit in that distribution. And then you can see here some extreme outliers in these cases. And the most interesting view was actually looking at the number of days between prescriptions. So, okay, if I'm getting a normal prescription of 30 pills, but I'm getting it like every other day, I'm kind of cheating the system. So I had a view that looked at how much I was getting filled at the pharmacy on a particular day, and then I was looking at the days between my prescriptions. So how often was I going to get my pills filled? So that to me, I had a couple of these visits. I was able to find that in my data, and I think that was the clincher, and I'll show you why. I'm just going to pick on Oxy here, probably because I listened to Eminem a long time ago back in the day, so I think he rapped a lot about Oxy, and so that was stuck in my head. But and so the first thing I saw with, I forgot to mention, I'm actually using the new cluster feature in version 10, if we have time, which we don't, unfortunately. But clustering, I'll mention right now, is great visually to understand how maybe there's a groups of outliers. If I pick on one of these other drugs here, you'll see there might be one with maybe some red. So basically I use clustering to tell Tableau to automatically cluster my data. It's looking at things like it's trying to cluster either the prescribers or the patients in terms of how much, in terms of dollar amount they're getting in prescriptions and also the quantity they're getting in the prescriptions. So Tableau, it's a great start. I think if you saw Tuesday morning where they announced some enhancements to that, because one thing I have to do if I want to go in and look into what is Tableau doing, how is it creating the clusters, what do those clusters mean, I have to actually go into the viz, open up, click on the describe, and view the model. If I had more time, I would show you that. But in the new version, you will not have to do that. I can click on a cluster and automatically get a tooltip that will tell me, here's some characteristics of that cluster. I find that very helpful visually in terms of outlier detection. But let me go back to picking on Oxy. And so this is the first time I was just scrolling through this data set, and the first thing I saw was this one individual way out here had an average dispense quantity of 690 pills, and that's compared to 157 in the data set, and $94,000 in payment. So the first thing I did was, okay, I want to learn more about this individual. Clicked on him on the data set. On my box and whisker, I can see that this individual's individual transactions have been, or his prescriptions have been, they're highlighted here, have been several of these outliers. The most interesting thing was to see how often they were getting 900 pills, and that was in 9 days of the last, and then even getting 900 pills again within 23 days. So you can see here, within 10 days, within 9 days, they're getting prescriptions, and that just to me was, I asked my wife, I said, what do you think that is? And because again, we don't want to assume fraud and waste abuse. She said, that's fraud, that's pill, we don't want to. So in this case, this is a prototype, but I would hand that over and say, there's something sketchy going on here, and someone has to look into it. So let me talk a little bit more about how I would enhance that. And so this is similar to some of the work we did at Blue Cross supporting our Special Investigations Unit. We were not the experts in fraud, waste, and abuse. Our specialists were, but we were experts in Tableau and understanding the data in our warehouse, in multiple warehouses, because we had to go across different lines of business in different warehouses. But the key here was building prototypes, getting them data extracts, so using Tableau as a data server so they can go out and do it themselves. This group now has been, I keep in touch with them, and they do amazing things, and I expect them to see presenting at a Tableau conference someday. But this is just kind of like the Tableau cycle that we do to build some of these dashboards for investigators. How would you enhance these? If there wasn't this thing called HIPAA, and I could actually share data on where people live and where the providers are, we would add some geospatial views to this dashboard. I will start looking at patterns of drive times between patients, providers, pharmacies. I would use some clustering techniques to then identify if there's any patterns of providers that have a lot of people that live in a certain radius or even a certain neighborhood. And I learned some of these techniques, I think it was 2 years ago at the Tableau conference when not even a health insurer, but Allstate was actually presenting on some of these techniques. So I took that and I went back to our SAU. I said, we got to start getting the geo coordinates for some of these individuals so we can start visualizing things like driving distance. Graph databases, looking at relationships between the individuals that I'm looking at, so my suspects that I'm looking at my data set, and which physicians are prescribing the medication. And then I want to also see who else is going to those. Do I have a cluster of individuals or providers that are working together in some sort of collusion? And then I mentioned the clustering technique. Graph databases, I will tell you, if you've been working with relational databases, it's definitely a new way of thinking. It's like going from relational to Hadoop and big data in unstructured data. It's a NoSQL database. Graph theory has been around forever, for hundreds of years. But basically, it's a different way to store your data and to query your data. And so I think this is a great complement, and I've been waiting. If you go out to the Tableau Ideas webpage, I have an idea, get a connector for what's called Neo4j, which is the one I've been using, because having that interactivity into Tableau would just add, again, another perspective that I can do things like fraud, waste, and abuse without having to go to an outside tool. Good news is someone did create a web data connector for Neo4j, which I believe is probably the most popular and robust, and also free in some cases, graph database. In this case, this is just an example. I was actually trying to build out this model to show you guys, and actually this morning was actually almost, I was so close to getting it at the point where I could integrate it in Tableau. I just couldn't get there. I'm losing my geekiness in terms of my skills. But this is just an example of modeling how I would model this data. I would use, in Neo4j example, I'd use a query language called Cypher to actually insert this data from, say, an Excel spreadsheet or a relational database into my Neo4j. I would then connect Tableau to the web data connector that some wonderful individual has created, and the link is down there on GitHub. But then once I have that connection, I can start working and interacting with data in Tableau and Neo4j. So these are the next things that I'm working on as part of this data set and hopefully someday I'll be able to demo it for any of you. So, any questions?
Chris, one quick question. You guys, whenever you're trying to do relationships between people, don't be afraid to go out and use social media together. So we do that a lot. So we'll find someone who is maybe a person of interest, and then grab all their friends off of Facebook and Twitter, which there are vendors. There's a vendor here in Nashville that does a really good job at that. Then we match that up with customers to see if there's a customer that is also a friend of maybe a cashier who is constantly giving away cigarettes and batteries. All right, so because the inventory is shrinking. So don't use social media. Unfortunately, it works against a lot of people, but it's another great way to match up people, cashiers and people that are doing things differently. Something to think about.
And I just wanted to say really quickly, if anyone would like a free copy of the book that Matt referenced, I have a closet full of them. I need help sleeping at night sometimes. But I'm happy to, I think I'm the reason it might be on the bestseller list. But it is really interesting. It's based on surveys we did with over 360 people at organizations focusing on chief audit executives, data analysts, and it really covers where people are today. The interesting stat in that book was that 88% of people really see an increase in the use of data analytics in the next 3 to 5 years. So a lot of people are at their infancy. This book is a great intro to that. It's kind of like a 101 with ideas of where people are and where they'd like to go. So if you're interested in a copy of that, just see me afterwards, give me a card, or I've got a few of these guys, and we're happy to send it to you.
What is the book value?
Priceless, priceless, my friend, priceless.
It's on the IA website, I think it's $39.95. After tax and shipping, I think the price goes up to $44. So as long as your gift element is under $50, you're
Wow, he knows about that one.
anybody from GM here, they can't take 10 cents.
So if there were other questions, apologies, I just wanted to get that through.
Awesome.
Okay.
Thank you for coming.
What do you mean?
I could have given you more time.
I said, actually.